Introduction. Rutherford established that atomic nucleus is the central core of every atom, which contains entire positive charge and more than 99.9% of the mass of the atom, whereas the size of an atom is of the order of 10 to the power minus 10 m. The size of atomic nucleus is of the order of 10 to the power minus 15 m. Thus, most of the space around the nucleus of an atom is empty space. Atomic masses. The instrument designed for this purpose is called a mass spectrometer. The unit in which atomic and nuclear masses are measured is called atomic mass unit, or AMU. One atomic mass unit is defined as 1/12th of the mass of an atom of C612 isotope. Nucleus size. Experimental measurements show that volume of a nucleus is proportional to its mass number A. If R is the radius of nucleus assumed to be spherical, then its volume 4/3 pi r cube is inversely proportional to A, or R is inversely proportional to A to the power 1/3, or R is equal to R0 A to the power 1/3. Nuclear density. Density of nuclear matter is the ratio of mass of nucleus and its volume. Isotopes. Isotopes of an element are the atoms of the element which have the same atomic number but different atomic weights. Isobars. Isobars are the atoms of different elements which have the same atomic weight but different atomic numbers. Isotones. Isotones are the nuclides which contain the same number of neutrons, that is, in their E's, A minus Z is equal to N is the same. Nuclear forces. Nuclear forces are the strong forces of attraction which hold together the nucleons, that is neutrons and protons, in the tiny nucleus of an atom. In spite of strong electrostatic forces of repulsion between protons. Nature of nuclear forces. A Japanese physicist, Yukawa, postulated in the year 1936 that nuclear forces between nucleons arise on account of continuous exchange of particles called mesons between the nucleons. Later on, these particles were detected experimentally. They were found to have a mass about 270 times the mass of an electron. Three types of mesons were detected. Mesons carrying no charge were called neutral pi meson, pi to the power 0. Mesons carrying unit positive charge each were called positive pi meson, pi to the power positive, and mesons carrying unit negative charge each were called negative meson. Mass energy. According to law of conservation of mass energy, the sum of the mass energy of a system of particles is the same before and after an interaction. Nuclear binding energy. Binding energy of a nucleus is the energy with which nucleons are bound in the nucleus. It is measured by the work required to be done to separate the nucleons and infinite distance apart from the nucleus so that they may not interact with each other. Every atom exists only in electronic configurations corresponding to discrete energy states called the stationary states. Likewise, we talk of nuclear stationary states which represent nucleonic configurations in which a nucleus exists. The stationary state of lowest energy is called ground state of the nucleus. Packing fraction. Packing fraction of a nucleus is defined as the mass excess per nucleon. Thus, packing fraction is equal to mass excess by mass number, which is equal to m minus a by a. Nuclear stability. The very large repulsive electric forces between protons should cause the nucleus to fly apart. Nuclei are able to stay together despite the repulsive electric force between them. Because of a much stronger force called the nuclear force, it is the attractive force that acts between all nucleons in the nucleus, and this force is much stronger than the Coulomb repulsive force between protons. Radioactivity. Radioactivity is therefore the property by virtue of which a heavy element disintegrates itself without being forced by any external agent to do so. The radioactivity must be property of heavy nuclei only. Three types of radiations. One kind of radiations with least penetrating power, that is the one which would stop first, was named alpha rays. The other kind with a comparatively larger penetrating power was called beta rays. The last kind with maximum penetrating power was called gamma rays. It should be clearly noted that all the three types of radiations need not necessarily be emitted by one radioactive element. Laws of radioactive disintegration. Nature of alpha, beta and gamma rays. This is the method used to show the nature of alpha, beta and gamma rays. The sample of radium is placed in a small cavity drilled in a lead block. The lead block checks all the rays. The radiation coming out of the cavity is subjected to an electric field provided by two plates. Then, the alpha rays are deflected through smaller angles towards the negative plate. The beta rays are deflected through larger angles towards the negative plate. The gamma rays remain undeflected as opposite charges attract each other. Thus, we conclude that alpha rays consist of positively charged particles, whereas the beta rays consist of negatively charged particles, and the gamma rays were undeflected. They could be waves or uncharged particles. Radioactivity is a spontaneous process which does not depend upon external factors like temperature, pressure, etc. During disintegration of an atom, either an alpha particle or a beta particle is emitted. Both of these particles are never emitted simultaneously. The emission of alpha particle from an atom will change it into a new atom whose charge numbers is reduced by 2 and mass number is reduced by 4. The emission of a beta particle from an atom will change it into a new atom whose charge number is raised by 1 without any change in its mass number. The number of atoms disintegrated per second, that is, rate of disintegration of radioactive atoms, at any instant is directly proportional to the number of radioactive atoms actually present in the sample at that instant. This is also known as radioactive decay law. Half-life of radioactive element. Half-life of a radioactive element is defined as the time during which half the number of atoms present initially in the sample of the element decay, or it is the time during which number of atoms left undecayed in the sample is half the total number of atoms present initially in the sample. It is represented by T. T is equal to 0.6931 by lambda. Average life or mean life of radioactive element. Average life of time of a radioactive element can therefore be obtained calculating the total lifetime of all the atoms of the element and dividing it by the total number of atoms present initially in the sample of the element. Alpha decay. It is the phenomenon of emission of an alpha particle from a radioactive nucleus. The difference between the initial mass energy and total mass energy of decay products is called disintegration energy O of the process. In general, alpha decay is represented as Zx to the power A tends to Z minus 2y to the power A minus 4 plus 2He to the power 4 plus Q. Beta decay. It is the phenomenon of emission of an electron from a radioactive nucleus. In general, we can write Zx to the power A gives Z plus 1 y to the power A plus minus 1 e to the power 0 plus Q, where Q is the energy released in beta decay. Gamma decay. It is the phenomenon of emission of gamma ray photon from a radioactive nucleus. The Y minus decay can be represented as Zx to the power A gives Zx to the power A plus Y. Artificial and induced radioactivity. This phenomenon of disintegration of otherwise stable nuclei by bombarding them with suitable projectiles is called artificial radioactivity. If the bombarded element keeps on indistigating, even after the bombardment is stopped, the phenomenon is called induced radioactivity. Nuclear reaction. A nuclear reaction represents the transformation of one stable nuclei into another nucleus by bombarding the former with suitable high energy particles. Nuclear fission. Nuclear fission is the phenomenon of splitting of a heavy nucleus, usually A is greater than 230, into two or more lighter nuclei. In the masses of final product, it found to be slightly less than the sum of masses of the reactant component. This difference in masses is called mass defect. Nuclear chain reaction. Nuclear chain reaction. In the nuclear chain reaction, mainly used as the uranium-235 nuclei as neutrons. Here, Fp represents the fission product. In nuclear chain reaction, firstly, neutron is colliding the uranium-235 nuclei. The nuclei are split into Fp and 3 secondary neutrons are produced. Then these 3 secondary neutrons again collide on the other 3 uranium-235 nuclei and produce 9 neutrons, which in turn can bring about the fission of 9 uranium-235 235 nuclei, and so on. Thus, this type of continuous reaction is called chain reaction. In this chain reaction, large amount of energy will release in a short time. This process is led to the discovery of the atom bomb. In this chain reaction, the following factors are reduced its effect. They are leakage of neutrons from the system, absorption of neutrons by impurities, absorption of neutron by uranium-238, critical size. This fission of 92U-235 by thermal neutrons is represented as 92U23 plus 0N1 gives 56Ba141 plus 36Kr92 plus 30N1 plus Q. Now the three secondary neutrons produced in the reaction may bring about the fission of three more 92U-235 nuclei and produce 9 neutrons, which in turn can bring about the fission of 9 92U-235 nuclei, and so on. Thus, a continuous reaction of 9 92U-235 nucleus and so on. Thus, a continuous reaction called nuclear chain reaction would start and a huge amount of energy will be released in a short time. Nuclear reactor. It is a powerful device wherein the nuclear energy produced is utilized for constructive purposes. A nuclear reactor is based upon controlled nuclear chain reaction. The main components of nuclear reactor are nuclear fuel, moderator, control rods, coolant, shielding. Nuclear fusion. Nuclear fusion is the phenomenon of fusing two or more lighter nuclei to form a single heavy nucleus. Solar energy is the energy obtained continuously from the sun and the stars. It is estimated that the sun, which is a medium star, has been radiation 3.8 into 10 to the power 26 joule of energy per second for billions of years. Controlled thermonuclear fusion. Controlled thermonuclear fusion is the basis of fusion reactor, which is the future source of unlimited and unpolluted energy. Nuclear holocaust. Nuclear holocaust is a name given to large-scale destruction and devastation that would be caused by the use of nuclear weapons. Radiation hazards. Radiation hazards are the harmful effects on an organism caused by radiations.